Okay, so now we're going to be solving this problem. So let's start solving the problem. At first, what you need to know is you need to know that you need to determine where the displacement is. So we already have done this problem, so we know that the unknown is here and the unknown is theta. So in this method, what you need to do is the unknown's point. So where the unknown is, so whenever you're determining an unknown, so this is the unknown is at B point. So every adjoining point that is with B point will be given a fixed support. In this case, they're already having a fixed support, but if they didn't have a fixed support, they would have done that. So I'm drawing the new diagram here. There you go, the diagram for the deflection. There you go, and here the unknown is theta B. So let's write up theta B here. And we're going to consider all the adjoining points to be in fixed support. There you go, they're in fixed support. Now they're in fixed support and there is a rotation that is pushing like that. We're going to determine the deflected shapes of the members. So you can easily determine that from our previous structural knowledge. So let me give the blue color for the displaced shapes. Since this force is pulling this member with this member BC upwards, so this is what it is going to look like. This is going to look like something like this. There you go. And this thing is also pushing this member BD towards the right direction, if you can see, right? So from there, we can draw it like that. So that's the deflected shape. And this theta B, if you look closely, this theta B is rotating like that, so it's going to push this member AB downwards as well. So if we draw the deflected shape for that, the deflected shape is going to be something like that. There you go. So we have drawn up the deflected shape, and from previously we had talked about that we need to memorize the deflected shape forces. So now that we have drawn the deflected shapes, so we can easily give them the forces. So the forces here are going to be in this direction. We have S4, there you go, and then in this direction we have S3. Okay, right over here, if we look similarly here, this is going to be our S3 prime. You know why I'm placing that prime? Because the difference in length. This is 5, this is 5 feet, 5 feet. Here we have 10 feet. Okay, right after that we have, there you go, we have S4 prime there. Similarly, if you take a look at here, there's going to be a force in this direction, a moment in this direction, we're going to be S3 prime, and similarly there is going to be S4 prime. Okay, so I'm not writing up the forces, I'm just writing up the moments because the unknown is theta B, and to determine theta B we just need the moments, we do not need the forces. So I'm not drawing up the forces here, but if you wanted to, you could have drawn up the forces. For example, you could have drawn this force, a force in this direction there, another force here in this direction, and etc. from the diagrams that we have seen previously. Okay. So now that we have the forces, we can easily develop the equation. So we need to see which forces are being associated at point B. If you look here, not forces, sorry, the moments. If you look here, you can see that this S3 prime right over here is being associated with point B. So is this S3 prime, and so is this S3, right? These things are being associated with point B. So if they're being associated with point B, we can easily determine the equation for solving point B. So the equation, since the unknown is at point B, we're going to take the equation at point B. So we're going to write out summation of moments at B is equals to 0, where the moments are, we have 2 S3 prime plus S3 into theta B equals to 0 minus, and let me just first say that this is the K value. Remember, this is the K matrix. Right here we have the displacement vector, which is theta B. Right over here we have the Q, and here we're going to place the value of f. So you can see that we are still doing k into u equals to q and f. So some of you may wonder that how is theta u and how this moment equation is formed. So previously we have seen that k, when stiffness is multiplied with displacement, we get force, right? Similarly, when stiffness is multiplied with rotation, we get moment. So that is how we form this moment equation. Okay. All right. So right here q was 0, and if we go back, we can easily calculate the f value, but since we already have calculated the f value previously, I'm just going to go back and take in that f value. Okay. Let's see, where is our f? There you go. So our f was minus 6.25 and plus 16.67. So if we calculate that in our calculator, 6.25 plus 16.67, then we're going to get 10.42. So that is going to be the value there. There you go. We're going to write up 10.42. And using this equation, we can easily determine theta b, right? And you can see that this equation is the same equation that you would have gotten if you had used the matrix format, right? And we can easily calculate the S3 and S3 prime as well. We have already calculated this S3 and S3 prime for this problem. We solved it using the matrix. See, here is the S3, here is the S3 prime. So we have all the values except for the theta b, and we can really get that. And if you look here, you can see this distance matrix is 2S3 plus S3 prime. Here I called the BD members as S3, but in the equations method, I just changed the name. It doesn't matter because the things are the same. See, you can see that the K matrix, the Q, the F, the unknown, they're all the same. So we just did what we would have done using the metric system, but we have used the equation system. So in this case, equation system actually helps us to reduce some steps, because we are not required to form individual KAB, KBC, KBD and then formulate the K from them. We can easily formulate the K. But the problem here is that you need to memorize the diagrams, and you need to have a firm understanding of how forces and moments affect the deflected shape of members. So if you're weak at determining how the deflection is going to look like, then this method can be quite tricky for you. So this method is not a must, because the metrics method is what we're going to be focusing on, and that should be the focus point. Because when we are going to be applying computer programming or softwares to solve the problems, the softwares and computer programming are usually based on the matrix forms, not in the equation forms. Well, the equation pops up once you use the matrix, but formulating just the equation without the matrix in computer programming and softwares becomes quite a challenging feat. That is why using the matrix is more simpler. I'm just covering the equation because this is a possibility, so I thought why not, let's just mention that and how it works, so that if any of you are eager, you can even try that out. Okay, so yeah, that is it for this video. Thank you very much for watching. I'll be seeing you in the next one.